Welcome back, Physics 30. This is part B of speed velocity 1. So we left off with this. We're doing number 5. First question, what is meant by interpolation? So looking at graphs here, going within the data to get information. And then how is speed calculated from a distance time graph? Distance versus time, distance divided by time. Really what we're doing there is we're figuring out the slope of 2 points, and distance divided by time, rise over run, change in y over change in x, it's equivalent. That's actually what we're doing here. And similarly, if I had a displacement versus time graph, once again figuring out the slope of that will give me velocity. So that's an important key point here to start. If we have our information in the graph, calculating the slope is speed or velocity. So here we have a graph here. Yours looks a lot neater than mine. This displacement versus time graph shows the positions of several runners at various times. Determine the velocity of each of the runners. So here we have runner A, runner B, runner C, and you can see here that I mentioned here the fastest person must be B because it has the higher slope, and since slope means velocity, that's the largest velocity. So the easiest way to do this is to pick 2 points. I picked the first point and the last points as my two that are looking on the graph. So A, 0, 0, B, 0, 0, C, 0, 4 are both the starting points for these ones. And then over 12 up 6, over 12 up 10, over 10 up 10. So all of these have the same formula here. V is equal to D over T, but we're looking at a change in displacement, change in time, so I narrowed it down to final displacement minus initial. Final time minus initial time, just like when you figured out slope in math class, y2 minus y1 over x2 minus x1. So if I'm looking at this first one, 6 minus 0 over 12 minus 0. So that's my t1 d1 point, t2 d2. So I get plus 0.5 meters per second. You should include the plus sign because it is a direction. Over here, my second displacement minus my first displacement, 10 minus 0, over my second time minus my first time, 12 minus 0, so plus 0.83 meters per second. And then lastly, 10 minus 4 over 10 minus 0, as indicated over here, plus 0.6 meters per second. So you can see that yes, I do get my largest slope, which is equivalent to my largest velocity for part B here. And you can visually see that it's larger than the rest of them. Okay, we have another one here. We have displacement versus time graph, a dog running along a track. And if you look at the various points here, they correspond to 2, 2, 4, 4, 5, 5. What is the dog's position at 4? Now be careful here. It's a position versus time graph. So if it's asking you for a position, you just simply read off the graph. So at 4 seconds, 4 kilometers. Now it's a very unrealistic case because this is a kilometers and seconds, so it's a very quick dog, I guess. So 4 kilometers from the starting point after 4 seconds. Very quick dog. What is the dog's displacement in between 2 and 5 seconds? So at 2 seconds, the dog had gone 2, 5 seconds, 5. So the difference here, 5 minus 2, so that's a difference of 3 kilometers plus. And then finally, what is the velocity? So in the position time graph, velocity is really the slope of the line, and you can see that's going to be a slope of 1 because 5 minus 2 over 5 minus 2, we get 1 as an answer, plus 1 kilometers per second. And yes, that's a wow there because that's a fast dog. Okay. Lastly here we have a graph that looks something like this. Once again, yours is neater. I had to redraw mine in here. So it's a delivery truck whose driver is trying to find a certain house. So obviously the truck was moving here. Here time is passing, position isn't. Then going in reverse direction, going forward again quickly, going forward again slowly. And notice here section A, B, C, D, and E, start, finish, start, finish, start, finish. So I labeled those points there, 0, 0, 10, 150, 20, 150, etc. That'll really help you out to figure out the velocities in each of those sections. So down here, what is the truck's position at each of the following times? So at 10 seconds, we're on 150. At 15 seconds, 150. 30 seconds, 100. 45 seconds, approximately 350. Or yeah, 45 seconds. And then lastly, at 50 seconds, you can see plus 140. And technically, position mean we need to have a displacement with the direction and a starting point. So technically, from the start, I should have for each of those. So plus 150 from start, plus 150, etc., all the way to the end. And then lastly, the velocity each of the intervals. So if we look at the first one, my second displacement minus my first, 150 minus 0 over T2 minus T1, 10 minus 0. So I get plus 15 meters per second there. So pause the video right now and work through the rest of them and see what you end up. Then turn the video back on and see how you made out. Okay, if you had a chance to do that, you can see here, obviously the velocity during section B is 0 because the position isn't changing at all. 150 minus 150 over 20 minus 10, and yes, we get 0 on top, just simply going to give us 0. The next one, our second position is 100, first one is 150, so it's actually 100 minus 150. Don't be concerned about a small number, subtract a big number, that's fine. And then 30 minus 20 in the bottom, so we get negative 5 meters per second. So that just means the direction is different. We're going backwards. And the final two movements, 300 minus 100. So 300 minus 100 over 40 minus 30. Once again, your y-axis change divided by your x-axis change, plus 20 meters. And lastly, 400 minus 300 over 50 minus 40. And you can see we're going a lot slower there, and you can see that from the graph. The slope is not as big in section E as it is in section D. Okay, so those are your final answers. Hopefully you made out all right. I think we have one more page here just with some vocab here. Speed, just simply distance over time. So if we are, and just by using the word speed, it's implying that it is a constant movement. So you're not speeding up, you're not slowing down, a constant distance over a constant time. So for example, cruise control, 100 kilometers per hour for a certain time interval. Average speed, that implies that you've been changing your speed throughout, and we're looking at the average. So your total distance divided by your total time. So you could be stopped traveling, stopped at a stop sign, then continue going. So it may be changing, and you have to see what would you be doing on average to do that same movement. So total distance over total time. And lastly here we have velocity. Change in displacement over change in time. Direction is required here, and also a size. Okay, so there you have it. That's Unit 1D, speed and velocity. See you next time.